Hello, everybody. My name is Mr. Chandler. I'll be talking to you today a little bit about extending your knowledge of from our what we've graphed this so far this 6 weeks, which is position time graphs. I'm going to talk to you a little bit about what happens when the graph is curved. So we're going to go through some examples here real quick, and we'll take a look at what happens in these situations. So we're going to start off with Susie here, and Susie is at a red light, which means she stopped. Well, of course, this is Houston, so maybe she blows through it, but we'll pretend that she's a good driver and she stopped at a red light. And she, like goes green, she's going to gradually speed up. So we know already, you should remember hopefully, that we said that before the slope of a position time graph is the velocity, right? The slope is the speed of the object. I believe we've covered that so far this year. If not, well, now you know. The slope, rise or run, it is the velocity. So what happens when someone isn't going at a steady speed? What if they're getting faster and faster and faster? That means that our graph is going to be curved. So it's going to look something like this. All right? And the reason why it looks like this is because if you look at the tangent line of that graph, and I'll get a different color for this, the tangent line is a line that only intersects a curve at one spot. So I'm going to kind of freehand some tangent lines here. So it's going to be like this, and then this, and then here. And hopefully you can tell that these tangent lines are getting steeper, steeper, steeper. And we discussed many times in class that the steeper the line, the faster the object is going. And so you get a curved line like this, it's going to show that an object is speeding up. It's getting steeper and steeper and steeper. So when you see a curved line, now you know, okay, a curved line on a position versus time graph. It's important to remember that all of these rules we teach you kind of really only work for certain kinds of graphs. So a curved line like this, like the white line you see, on a position time graph is going to mean that an object is getting faster and faster and faster. It's speeding up. What if Susie is cruising along at her top speed when she sees a stop sign up ahead? And so she hits the brakes and comes to a stop. What would that look like? What would this look like on a graph of position versus time? Well, she's coming to a stop. So it means we're going to get flatter and flatter and flatter. Remember, the flatter you are, a totally flat line means you're not moving at all, right? You're at rest. So she is moving and she's going to slow down. So the line needs to become flatter, right? So we're going to start off with a little bit of slope, and then we're going to get flatter like this. So what this graph is showing, and again, look at the tangent lines. We have some steepness here in the beginning. It's a bad tangent line, but you get the idea hopefully. Some steepness there, flatter, 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 and then eventually we're just totally flat, right? So we're getting flatter and flatter and flatter. That means that we are slowing down because the slope, the steepness, tells us about our velocity. So getting flatter means slowing down. So that's one we could look at for slowing down. What if she does something like this? Susie is driving along and realizes she forgot something back at home. So she slows down, makes a U-turn, and then speeds back up in the other direction. What would this look like on a graph of position versus time? So in this one, she's not just going to slow down and speed up. She's actually going to do both. She's going to slow down, turn around, and speed up in the other direction. So this is an interesting one. So I'm going to start here at the origin. So we're going to speed up. We're already going some speed, right? She's driving along. She's already driving, so she already has some velocity. So she's going like this. And then she forgot something at home. She realizes it. She slows down. Slows down means we're going to get flatter. So we're going to flatten out. And then she makes a U-turn and speeds up, back up in the other direction. So then she's going to speed up in the other direction, get faster, faster, faster. So this is what this graph would look like. So it turns out that our position time graphs can not only tell us about whether or not we're speeding up or slowing down, it can also tell us what direction we're moving in. So these graphs, these tangent lines are all kind of going up, right? Like up on the graph, which means we're going in some positive direction. It could be to the right. Usually we call positive to the right. I know I mentioned that with my classes. So we have a line here, tangent line going up, kind of positive, getting a little flatter. Still going up though, flatter, still going up, flatter, still going up. And then we have totally flat. So you notice that these tangent lines, they're all going up in the positive direction, but they're getting flatter. And then suddenly we have lines that start to go down. And they get a little steeper, and a little steeper, and a little steeper. Because what we're showing here is that now we have turned around. We're going in the negative direction. Now the graph's going down on the graph, which means we've turned around in the negative direction. And we start off pretty flat, but then we get steeper and steeper and steeper just in the negative direction. So this is showing us slowing down in the positive direction and then speeding up in the negative direction. Okay, that's what that would look like on a position time graph. Let's look at one more question here. What if we wanted to take this information and we wanted to turn it into a velocity time graph, which is something we have not covered yet, but we will cover it. But we're just kind of an extension, kind of a look ahead into some other things we'll be doing later on in the year, later on in the next few weeks. So Susie's driving along and realizes she forgot something back at home, so she slows down, makes a U-turn, and speeds back up in the other direction. What would this motion look like on a velocity versus time graph? This one always can be confusing because let's kind of go through this and see what she's doing here. Let's assume that initially Susie is going in the positive direction. So she's going, here's Susie's house, okay, and here's Susie's in her car, my awesome car, whatever, and she's going to the right. Okay, I know I cannot draw. I'll try this a little bit better. That's not much better. Okay, she's going to the right. Okay, and she's driving along, la la la, and she forget. Oh, I forgot my phone at home. I can't go anywhere with my phone. I gotta stop. So she stops. All right, she slows down, stops right here, turns around, and then speeds back up in the other direction. Starts slow, and then gets faster. And my arrows here are representing. The longer the arrow means more speed. So this is what the person is doing, right? So they start off going in the positive direction. We're going to call right the positive direction, and we're going to call left the negative direction, right? That's how we define these things. Right's positive, left is negative. That's what the signs mean in physics. And so how would this look on a velocity versus time graph? So now you got to be very careful. We're not graphing the position. I don't really care where she started. I want to graph her velocity. My velocity in the beginning was positive, and it was pretty high. She had a lot of velocity at the beginning. She was already driving. Okay, so I'm going to start up here in the graph somewhere. I'll just pick a point. I'll say right here. Okay, we're just going to get the shape of this graph. We don't want to work with the numbers right now. Let's get the shape of it. It starts up here somewhere, and she begins to slow down. Now look at the arrow. She's still going in the positive direction, right? She's still going in a positive direction, but she's slowing down because she has the brakes as she goes to the right. So that means a graph's going to look like this, right? Imagine there were numbers here. Let's actually put in numbers here just to kind of prove a point here. 1, 2, 3, 4. It's supposed to be 3, 4, 5, 6, and 7, and so on. Now look at my graph. As time progresses, what's happening to Susie's speed? Well, it starts off at 6, let's say, and then it becomes 5, and then it's 4, and then it's 3, and then it's 2, because she's slowing down. But they're still positive numbers because she's still going to the right. At some point, her velocity is here. That's right here. When it crosses the x-axis, that corresponds to this point right here. The moment she actually stops, right? The moment she stops, her velocity is 0. Now, she turns around, and now she's going in the negative direction, but initially very slowly. So we're going to have the graph going to keep going like this. And if you think about the numbers here, -1, -2, -3, -4, -5, you can see that initially my velocity is very small, -1, and then it gets bigger, -2, -3, -4, and so on. So you see it's the numbers themselves are getting larger. It's just the sign is negative. But remember in physics class, the sign just means the direction we're moving in. So this curve here would actually be the same graph, this line on a velocity time graph is the exact same motion that we saw before with this graph. They're the exact same thing. They're just displayed in different ways. One of them is a position time graph, which looks a certain way. And the other one is a velocity time graph, which looks a certain way. All right, so in the future, you will be seeing graphs like this and like this. So now you got a little leg up for what's to come in the future. Hopefully it makes some sense. If you have some questions, let me know. But anyway, there you go. That's a little extension for you, a little preview into the future. Thank you. All right, so now I'm going to ask you to show me what you've learned a little bit. I'm going to ask you to make some sketches. Before we do that, I'm going to just a little quick reminder, even though you probably remember this all stuff already. On a position time graph, remember that if we have a flat line, that means we're at rest. Right? Flat line means we're at rest. If we are a line going kind of straight, like at an angle like this, a straight line, this means we're moving at a constant speed. Right? We're not changing our speed. We're going at the same speed. Like we're in cruise control, so to speak, and we can go in positive direction, or we can go in the negative direction if we're going down on the graph. Right? This would be a negative constant speed. Sorry, my handwriting is very poor. And then, of course, we just talked about the curves, right? So we talked about curving up, but that means curving down, curving flatter, getting steeper, what those things mean. Then, of course, velocity time graph. We just discussed this briefly, but we'll give it a shot. It's just kind of a bonus thing. If a flat line on constant speed would be a flat line on the velocity time graph because it's showing that our velocity is not changing. So for example, this were 2 right here. As time ticks by, it's showing that our velocity is just always 2. It's not changing, right? But of course, this is at rest. This doesn't match up exactly, but so this graph would be like this graph here would match up with like this graph down there. Okay. Or if we're going the negative direction, we'd have a velocity time graph like this. So this graph here would match up with something like this. It's a straight flat line, but below the x-axis, right? Because numbers down here are like negative. So this is showing a constant negative speed because the slope is going down, or negative slope. So we'd have a constant negative velocity. As time ticks by, the velocity is always -2 the whole time. Okay. All right. So use this information to answer the next couple questions. All right. Here's the first one. Enrique is driving along in the positive direction at a constant speed. He sees a yield sign and slows down for a few seconds. He realizes no one is coming and speeds back up to his original speed. What would this look like on a position versus time graph, and what would it look like on a velocity versus time graph? So I want you in your own paper to sketch out a position time graph like this and a velocity time graph like this, and just give it your best shot. It is totally okay to be wrong. It's just kind of a bonus extra extension thing, so it's totally cool to be wrong. Just give it your best shot. So try these 2 first, and then you can pause the video right here, go and pause it, make the sketches, show your teacher. All right, now you've unpaused, hopefully now you're back. Now we'll try one more. All right, last one. Enrique is driving along in a negative direction at a constant speed when the cops start chasing him. He decides to try and outrun them and speeds up even more to his top speed. Finally, the cops catch him and shoot out his tires, and he comes crashing to a stop very suddenly. What would it look like on a position versus time graph? What would it look like on a velocity time graph? So we're going to draw a position time graph, like so, on your own paper, and a velocity time graph, like so, on your own paper, and just kind of sketch out what do you think the shape of these graphs would look like, more or less. Just give me the shape. Don't worry about numbers. Just the shape. Would it curve up? Would it get flatter? Would it go curve down? Stay flat? Straight line? That sort of thing. What would it look like, do you think? Just kind of in general, the general shape. All right. So see you in the video. Take your graph. Show your teacher. If it's me or Miss Dolan or Miss Rodriguez, to show whoever you got. We'll tell you if you're right or wrong, and we'll give you some pointers. And like I said, in the future, we'll be seeing this stuff again. So anyway, thanks guys for listening, and I'll see you around. Bye-bye.